I had a few people email me about how to solve these systems of equations when there happen to be fractions involved. So I wanted to work through this particular example in two ways. One, by getting rid of the fractions entirely, and then the other by keeping them. Either way, we should get the exact same answer. So let's go ahead and start working through that. So the problem I'm looking at, they asked us to solve this system by the elimination method. And so, of course, by the elimination method, our job is to make one of these variables just go to 0 for the coefficient by adding or subtracting some multiple of the equation, if necessary, of one to the other. So because I have fractions here, one method we can use is just to get rid of all the fractions entirely. So if I don't want fractions, if we remember at all from prior courses in math, if we don't want fractions in an equation, we can multiply everything in the equation by the least common denominator, and that should make these fractions cancel out. It'll change my numbers, but it doesn't change the equation. So for example, 1/3 x plus 1/5 y equal to 8. My two denominators are 3 and 5. Their least common multiple, so the number I can get them both to multiply to, not divide by, but to multiply to, would be 15. So before even going to this elimination method, I can just mess with these equations first. So I could take this entire equation and multiply it by 15. And so you'll notice by the fractions I wrote that as 15 over 1, just to remind us that when we multiply fractions, we multiply numerator with numerator and denominator with denominator. Same thing here. And over here I didn't have to do that because that 8 is not a fraction. But every single term in this equation will get multiplied by that least common denominator. So if I do this multiplication, I would get 15 over 3x plus 15 over 5y equal to, and 8 times 15 would give me 120. And then in the next step, if I actually simplify, remember, fractions are just asking us to perform a division. Sometimes that division is messy, like with 1 over 3, and sometimes it's more clean, like with this 15 over 3. 15 divided by 3 does divide evenly into 5. So now this equation, I'm going to write it down here so I can get to my elimination method in a moment, will look like 5x plus 15 divided by 5 is going to give me a nice number of 3. So plus 3y equal to that 120. And then I'm going to do the same thing to that next equation. So 1 over 6x minus 2 over 5y equal to -6. Again, I want a common multiple between these two denominators here of 6 and 5. Unfortunately, 15 doesn't work anymore because 6 does not multiply to 15, but I can get them both to multiply to 30 because they do both have products of 30 in their list of products. So I'm going to multiply this equation, everything, by 30. And again, with the fractions, I'm going to write that as 30 over 1 and then 30 over 1 for the multiplication. And here I'm going to just write that as 30 because this is not a fraction. And then over here, when I do that multiplication, 30 times 1 is 30. 1 times 6 is 6. And I have my x minus 30 times 2 is 60. 1 times 5 is 5. Y equal to -6 times 30 will give me -180. And again, now when I look at this and do the division that the fraction implies, I can do that division with a clean number. So 30 divided by 6 is going to give me 5x. 60 divided by 5 is going to give me 12. So minus 12y equal to -180. So rather than working with the equations we were given originally of 1/3 x plus 1/5 y equals 8, 1/6x minus 2/5 y equals a -6, I've changed them into this format of themselves, and I can still use this to solve my system of equations. And so if I'm going to use this to solve, I already have coefficients that match now with the 5s, so I could just do one equation minus the other one. So 5x minus 5x will give me 0x. 3y minus a negative 12y. Well, that double negative makes this an addition. So 3y plus 12y now is what I have. So plus 15y equal to, I have 120. Again, this double negative minus a negative 180 becomes plus 180. So 120 plus 180 is going to give me 300. And here I've got that elimination that I was seeking with that 0x. So now my equation is just 15y equal to 300. To solve that, I would divide both sides by 15. So I'm going to get y is equal to 20. So that is one of my solutions, is that y is equal to 20. And then once I have that, again with our elimination method, we just go back to any version of our equations. If you want to go back to the fractional version, these cleaner versions, it doesn't matter. Just pick one and you'll plug it back into one of them. So let's just say I felt like plugging it in here because I just felt like it. So I would have 5x plus 3 times 20 equals 120. So then that gives me 5x plus 60 equal to 120. Subtract 60. So now I have 5x equal to 60. Divide by 5. And I get x is equal to 12. So the system they gave me originally in those fractions, I don't have to keep them. I can clean up my equation. It's going to give me these answers. If I had kept my fractions, these answers would still be the answers we got when we solved. So right now we're saying our solution set is 12, 20. If you're a person who doesn't mind fractions, that's totally okay. We can also keep the fractions and still use the elimination method. It's just a little more work because of the fractions. So for example, if we go back to the beginning, 1/3 x plus 1/5 y equal to 8, and 1/6 x minus 2/5 y equal to -6. So again, I want matching coefficients. These two right now with those same denominator of 5 are the closest pair I have. So I would go with trying to match these two. I want this 1/5 to really be a 2/5 now. The only way I can do that through multiplication is to multiply everything in this equation by 2. And just like last time, because of the fractions, I'll write it this way here. So now this equation, I'm multiplying it by 2, and that's going to make it look like 2 over 3x plus 2 over 5y equal to 16. I'm going to leave that second equation alone. 1 over 6x minus 2 over 5y equal to -6. Here I have a 2/5 and a -2/5 now. I can just add these two equations together. These two will give me my 0y that I was seeking. 16 plus -6 is going to give me 10. Here, if I'm going to add these two fractions, 2 over 3 plus 1 over 6, I need a common denominator. So I'm going to multiply this one by 2 over 2. So 4 over 6 plus 1 over 6. Now I have 5 over 6. So this sum here gives me 5 over 6x plus 0y equal to 10. So that gives me this equation now. To solve this, I would have to multiply by the reciprocal. So x is equal to 60 over 5, which means x is equal to 12, which is the same number we got earlier. And once we have this, again, we can take this number and plug it back into any version of the equations we've worked with to get to our next solution. So let's say we plugged it in here. So 1 over 6, instead of x, we're going to put that 12, minus 2 over 5y equal to -6. When I multiply these, it becomes 12 over 6 minus 2 over 5y equal to -6. This is, of course, 2 when I do that division. Subtract the 2 from both sides. Negative 2/5 y equal to negative 8. Again, I can multiply by the reciprocal on both sides. This gives me my y. This would give me positive 40 over 2. 40 divided by 2 is going to give me 20, which is the exact same solution set we got earlier when we changed the equations by getting rid of the fractions. So either way that you choose to solve this, either keeping the fractions or eliminating the fractions like we did on that previous example, either way we'll get the same solution set here of 1220. I hope that helps. Thanks.